Hi, welcome to part 14 of the video series about vertical projectile motion. In the previous videos, we have learned how to draw acceleration, velocity, or position versus time graphs of an object in free fall. In this video, we are going to solve an example to see all this knowledge in action. A person standing on a balcony 30 meters above the ground tosses a ball upwards with an initial velocity of 9.8 meters per second. The ball travels upwards to a maximum height and then falls to the ground. Draw the following graphs: acceleration versus time, velocity versus time, and position versus time. Even though it is not specified in this example, in exam questions, while drawing the graphs, it is required to indicate certain points on it. We can start by calculating the time it takes the ball to reach the maximum height. During these calculations, we will accept upwards as the positive direction. We can use the formula V final is equal to V initial plus A times delta t to calculate the time it takes the ball to reach the maximum height. We already know that at the maximum height, the velocity of the object is equal to 0. In the question, it is given that the initial velocity is equal to 9.8 meters per second. Gravitational acceleration on the surface of the Earth is minus 9.8 meters per second square as it is acting downwards. After rearranging the equation, we get 9.8 times delta t is equal to 9.8. The time can be calculated as the ratio of 9.8 and 9.8, which is equal to 1 second. Next, we can calculate the maximum height of the object from the ground level. The formula which is generally used to calculate the maximum height is V final square is equal to V initial square plus 2 times A times delta x. Once more, we substitute the final velocity at the maximum height as 0. The initial velocity is 9.8 meters per second and the gravitational acceleration is minus 9.8 meters per second square. 2 times minus 9.8 times delta x can be moved to the left side of the equation as 19.6 times delta x. The square of 9.8 is equal to 96.04. The displacement can be calculated as 96.04 over 19.6, which is equal to 4.9 meters. This value is the displacement of the object from its initial position, which, according to the question, is 30 meters above the ground. Therefore, the height of the ball from the ground is the sum of its initial height of 30 meters and its displacement above this point, which is 4.9 meters. The ball will be 34.9 meters above the ground when it reaches its maximum height. The third quantity which we can calculate is the velocity at which the object will hit the ground. Once more, we can use the formula V final square is equal to V initial square plus 2 times A times delta x. This time, the final velocity is unknown. The initial velocity is 9.8 meters per second and the gravitational acceleration is minus 9.8 meters per second square. Initially, the ball is at the height of 30 meters and at the end, it is on the surface of the ground. It has displaced 30 meters downwards. Therefore, the displacement of the ball is equal to minus 30 meters. The value of the expression on the right side is equal to 684,04. The final velocity can be calculated by taking the square root of this value. The velocity at which the ball will strike the surface is equal to minus 26.15 meters per second. As we know, the square root of any rational number can have both positive and negative values. The reason we are using the negative one in this example is that while striking the ground, the ball moves downwards. We can recall that at the beginning of the question, we have chosen upwards as the positive direction. In this case, downwards becomes a negative direction. The last quantity we are going to calculate is the time it takes the ball to reach the ground. There are too many options to calculate it. We are going to use the formula V final is equal to V initial plus A times delta t. While considering the entire motion, the final velocity of the ball is minus 26.15 meters per second. Its initial velocity is 9.8 meters per second, and the gravitational acceleration is minus 9.8 meters per second square. After moving minus 9.8 times delta t to the left side of the expression and minus 26.15 to the right side, we get the equation of 9.8 times delta t is equal to 35.95. Time is equal to 35.95 over 9.8, which is equal to 3.67 seconds. Once done with calculations, we can now start to draw the graphs. We will do so by plotting the simplest one, the acceleration versus time graph. On the screen, we can see all the information required in this and the following steps. While drawing the graphs, it is important to label and indicate the units of each axis. During vertical projectile motion, the acceleration of the ball remains constant. It is minus 9.8 meters per second square. It will remain so until the ball hits the surface after 3.67 seconds from its launch. The next graph we are going to draw is the velocity versus time graph. Once more, we must make sure that both axes are labeled properly and that the units are indicated as well. The ball is thrown upwards with an initial velocity of 9.8 meters per second and then reaches its maximum height after 1 second. During vertical projectile motion, the velocity versus time graph is a linear graph with its gradient equal to the gravitational acceleration. After reaching the maximum height, the ball starts to fall down. Therefore, its velocity becomes negative. That's why we continue to plot the graph below the x-axis. This motion continues until the ball hits the surface at the time is equal to 3.67 seconds. The velocity of the ball at this exact moment is minus 26.15 meters per second. Finally, let's draw position versus time graph. The ball is initially 30 meters above the ground. After 1 second, it reaches its maximum height from the ground, which is 34.9 meters. As it was mentioned in the previous video, while drawing a position versus time graph of a projectile, we imagine kicking a ball from the given point and then draw its path as the graph. The graph will have a shape of half parabola until it reaches the maximum height. After this point, it will fall down again by following a parabolic trajectory. The time it hits the ground is 3.67 seconds. In this video, we have solved an example where we have seen how to draw acceleration, velocity, and position versus time graphs. In the next video, we are going to solve one more example where an object will bounce off the surface. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.